Okay, so how to use the quadratic formula. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which means we can solve for x if we have an equation in the form of 0 equals ax squared plus bx plus c. We can solve the equation using the formula. Now notice this factor is perfectly fine, right? To x plus 3 and x minus 4, or sorry, x plus 3 and x plus 4. So the easier way to solve this would be by factoring for sure. But a here is 1, b here is positive 7, and c here is positive 12. So you can plug those in to the equation, and we'll get, let's see, negative 7 plus or minus the square root. B squared is going to be 49 minus 4 times a, which is 1, times c, which is 12, all over 2 times a. Okay, so negative 7 plus or minus 49 minus 4 times 12, it's 48. So this is plus or minus the square root of 1, which is 1, over 2. So if we take negative 7, subtract 1 from it, we get negative 8 over 2. So x equals negative 8 over 2, or negative 4. Or if we take negative 7 and add 1 to it, we get negative 6 over 2, which is negative 3. All right, which is what we would have gotten if we had factored, right? X plus 3, x plus 4, therefore x equals negative 3 or negative 4. All right, but the quadratic equation works. We can see it in one that we can understand what the answer is very easily. But here, we can't factor x squared plus 3x minus 2. So we could complete the square. That would be totally appropriate, completing the square. Or if we remember the formula, we can use the formula. We would get x equals, let's see, negative b, that's going to be negative 3, plus or minus the square root of b squared. So b squared is going to be 9 rather. Minus 4 times a, which is 1, times negative 2. I'm just going to actually put plus times 2 here and then make that a plus sign instead of writing it on a negative as another thing to mess me up. All over 2 times a, which is 1. And we're going to see what this is. Let's see, this is negative 3 plus or minus the square root of 9 plus 8. 9 plus 8 is 17. All over 2, and that's actually, that gives us two answers, right? X, we have a positive and a negative here, so we have two different answers, but we can just leave it that way. Those are two different x-intercepts if this thing were y equals, right? And then the last one, still using negative b plus or minus square root of b squared minus 4ac all over 2a. We have 1, 1, 1. We have all ones here. So let's see what happens here. So x equals negative b, that's going to be negative 1, plus or minus the square root of b squared, that's going to be 1, minus 4 times 1 times 1, all over 2 times 1. Okay, now there's a problem here. In here, we're going to wind up with negative 3, all right? So this equals negative 1 plus or minus the square root of negative 3 over 2. Now, you can't take the square root of a negative number. If you remember from the last video, when I moved the parabola above the x-axis and the little line I had disappeared, that little line was representing this length divided by 2, this length divided by 2. It was representing this plus or minus deal, right? Well, here, this plus or minus deal is imaginary. This is what's called an imaginary number. It doesn't exist. You can't take the square root of negative 3. You can't take the square root of any negative number. So in fact, if you have a negative value here, you don't have any values for x. You don't have any solutions to the equation that this statement is equal to 0. Right? But we have a special name for this part of the quadratic equation because of what it does here. The other thing that happens here, in addition to not having any solutions, is this parabola, if you imagine y equals this x squared plus x plus 1, if you imagine that, then this parabola would never cross the x-axis. The fact that this is negative means it will never cross the x-axis. So we call b squared minus 4ac the discriminant, because if if b squared minus 4ac is greater than 0, in other words, there are values when we go to take the square root, then the equation will have two solutions. Okay? And when we graph it, it's going to cross the x-axis. If b squared minus 4ac is less than 0, in other words, it's negative, we can't take a square root of it, then we wind up having 0 solutions. Okay? And the other situation is when it's equal to 0, right? When b squared minus 4ac is equal to 0. All right. When b squared minus 4ac is equal to 0, we actually wind up with one solution. And that's a situation where when you go to graph it, it actually just touches the x-axis. So visually, these look like this. The 0 solution ones look like this. And the 1 solution ones look like this. They just have 1 point. No points, 2 points, 1 point. If you have y equals a quadratic formula, a quadratic equation, you can use the discriminant to determine number of x-intercepts. If you have an equation, you can determine the number of solutions you should expect. All right, so that's the discriminant. This is use of the quadratic equation. We don't overemphasize the quadratic equation in Hopkins. We would just assume you complete the square, to be absolutely honest, but it is a nice shortcut. A lot of schools use this. It definitely winds up on the SAT, very popular topic, and a very common skill to learn.